Hello everyone, today I am going to talk about the multi-fluid double U-tube manometer. In this setup, one end of the manometer is connected to a pipeline and the other end is connected to a pressure gauge. The pressure gauge is showing 370 kilopascal. Now our task is to calculate the pressure inside the pipeline. Here, for that, we must first recall how to calculate pressure. Pressure is given by the formula P is equal to H rho G. So here H is height of the fluid, then rho is the density of the fluid and G is the gravitational acceleration. There are few important points need to remember. Number one is when we move downward through a fluid column, the pressure increases. When we moved upward, the pressure decreases. Along the same horizontal reference line in a single fluid, the pressure remains equal. Means pressure acting on the same fluid at the same reference line will be the same. Keeping this rule in mind, we can carefully calculate the pipeline pressure from the given manometer reading. Now, if you observe here, the pressure shown in the gauge is 370 kilopascal. This is the reference pressure connected one side of the manometer. If I draw a horizontal reference line before that, now pressure this point also the same P gauge. Now if I draw the horizontal reference line at that level, the pressure at every point along this line in the same fluid must also be 7 kilopascal. Now if you see here, then the bottom the water is there. Since both sides U-tube share the same fluid at the same reference level, the pressure at this point also be the same. Means whatever the pressure here, the same pressure will be here. Now if I go upward direction, means if we move upward from this level to this level, now pressure will decrease. So for in this point, if I calculate pressure, so that will be pressure gauge minus this height means 45 centimeter divided by 100, so we make in meter the density of the water, because in this column the water is there, and then gravitational acceleration 9.81. So if I calculate, so P gauge minus 4414.5. Now from here again we draw the reference line. Now here if you see in that tube oil is there, means again that same horizontal reference line in the both side of the that manometer, here the same liquid is there, so pressure whatever pressure at that point, that will be the same here also. So both side the pressure will be the same. Now from here to if I go downward direction, so now pressure will increase. So for that we know the pressure here, so that is P gauge minus 4414.5. Now because of this liquid height, so as we are moving downward direction, so pressure will increase. So plus 50 by 100, and the density of the oil is 790 into 9.81. So that will be, if we do the calculation, so that will be that P gauge plus 539.55. Now from here again if I draw the reference line, so if you see in that the bottom of the manometer, same fluid are there, means whatever pressure will be here, same pressure will be here. So now the same pressure will be there, so here pressure will be P gauge plus 539.55. Now if I go move from here to here, obviously we are going upward direction, so pressure will decrease. So now that we can calculate like that way. So this is the pressure here, and then we are moving from here to here, so that will be minus the 10 is the height, 10 by 100 into that mercury density into 9.81. So if we do the calculation, so that will be P gauge minus 12802.05. So now here the pressure is P gauge minus 12802.05. Again from here to here, if I draw the reference line from the middle of the pipe, so that height, so actually this should be here. Okay, so that is 22 centimeter. Okay, now we can easily calculate that. So we are going upward direction, again pressure will be uh, decrease, so that will be P gauge minus 12802.05 minus 22 means height is 22 by 100 into 700 means that the gasoline in the pipeline, so the density specific gravity is given 0.70. We have to multiply 1000, so that will be the density into g is 9.81. So if I do the calculation, that will be P gauge minus 1431279. So ultimately means that pipe pressure PP is nothing but P gauge minus 14312.79. Now we know that P gauge is 370 kilopascal, 370 into 1000. So we have to convert the kilopascal to pascal, minus 14 or something, 143 143 12.85. So it will roughly something 355,687.21. So ultimately PP will be nothing but 355.7 kilopascal. So now pressure at the pipeline is 355.7 kilopascal. That's it. Thank you.